sort of the second phase of our NXCAM webinars that we have going on. Today we'll be covering high-speed machining, 3-axis through 5-axis, presented by myself, Ian Scribner. Work here with CamLogic. With that, we'll go ahead and get going here. Try to keep it a little bit under the half hour and leave some Q&A here at the end. So real quick, who is CamLogic? CamLogic was founded back in 1995. We're out of Oxford, Michigan. Pretty much cover the Michigan, Ohio, Indiana, and Pennsylvania. Been in business, like I said, a little bit over 16 years. The solution or software and hardware that we provide is sort of cutting edge, both products and services. And we truly try to pride ourselves on dedicated customer service and support. There's three key areas that CamLogic focuses on. One of which is what we'll be chatting about today, products from Siemens, PLM, the CAD, the CAM, CAE, PLM, and PDM software. We also have another, let's say, division that focuses primarily on the 3D printing and rapid prototyping from 3D Systems. We also get into 3D scanning for reverse engineering or data compare. So a little bit about NXCAM. It's software that's well established in the industry. Have a slew of customers in nearly all industries, whether it be a company that a small, let's say, 1 to 2 man shop with just a single license, 1 or 2 machines, to large international companies that in nearly every sort of industry, whether it be automotive, aerospace, machinery. And we're also closely aligned with the Siemens Motion Control business side for the Siemens Sinumeric controllers, some out there may know of. NXCAM is one of the leading NC programming systems. It provides a wide range of machining capability. Today we're going to be primarily focusing on the mold and die machining. That requires special capabilities in machining hard tool steels. Also, other areas that NXCAM is extremely strong with is some of the machinery and equipment manufacturers often have prismatic parts suited for automated programming. This is where your Morisiki NT line or your Mazak Integrex line may come into play. And then there's also the complex parts, which typically always going to require 5-axis machining. Typical industries are going to be your aerospace or medical devices. So what we're going to focus on today is the 3-axis and high-speed machining, as well as into the 5-axis milling. And with NXCAM, there's a wide range of 3-axis machining capabilities, from your high-speed machining strategies, which we'll be covering, an intelligent rest milling for always calculating where there's material throughout the machining process, smooth cuts with some of the streamlining capabilities, and also automatic collision detection, and even down into the IS&V kits, which we'll be chatting about here in a little bit. So the first topic that we're going to discuss is the roughing side of NXCAM. Inside of NXCAM with the roughing methods, to assist with the high-speed machining, there's automatic multiple cut ranges with variable cut depths, which when you're calculating your tool path, it'll automatically calculate for areas where there's a ledge, so it'll automatically adjust your step down so that you'll have a constant material left at the end of the pass. High-speed machining patterns with some of the trochoidal tool path, but also some of the corner rounding, so that it'll also do acceleration and deacceleration maybe in our corners. And then the automatic in-process workpiece that we discussed a little bit earlier, which is basically going to always keep track of how much material has been removed when I do a secondary operation or a semi-rough. NX will automatically remember where there's material left and avoid areas that's already been cut. And NX CAM as well, so some great enhancements are what we consider safe cutting. And this prevents holder collisions based on the in-process workpiece. So as you see in the picture dialog here, as the 4 pictures kind of indicate, the first tool path, we would end up resulting in the tool holder crashing into the material as it cut down after the first step. NX CAM is smart enough to look ahead and automatically detect where the tool holder is going to hit and automatically offset it over. So we'll end up with a resulting tool path like we see in the final picture down in the bottom right there. Also, NX will automatically give a report back on what the shortest tool can be to make a safe clearance tool path for that area. Some other enhancements with NX CAM when it comes to the 3-axis and high-speed machining is the ability to automatically output an arc or line based on part geometry. For instance, in the top picture, you'll see that if we had all those tiny line segments, we're going to end up with a very choppy tool path, which obviously is going to result in our part a little bit more let's say, benching on our part at the end of it. NX has the ability to look at that part and adjust and create just arcs and smooth lines, even if it's just a NURB surface. Some other practices that NX CAM provides is what is considered plunge milling. Not an operation that we see a lot here in the Midwest, but it's good to point out that we do have the ability to produce plunge milling tool path. It's great for high volume material, uses the shortest possible cutting tool, and again, we'll keep track of the in-process workpiece. Along the lines of the IPW or in-process workpiece, NX does a great job calculating rest milling, automatically identifying any machine uncut regions. This optimizes multi-stage roughing. So in instances where we're maybe doing some 3+2 machining or using a rotary table and we're indexing the part, NX will automatically keep track of where there's material and on the next operation avoid creating tool path in an area where the material has already been removed. It leaves consistent material, obviously, for your finishing tool paths. Speaking of finishing tool paths, I'm going to cover some of the cutting methods that NX CAM brings to the table. Inside of NX CAM, there's a variety of different finishing tool paths available. And the wide range of finishing techniques for a superior surface finish, anywhere from some of the Z level, which we'll be talking about here in a second, along with lace cut, and even into a streamline method that only a software like NX CAM brings to the table. So Z-level machining is ideal cutting techniques for steep areas. We have the ability to smooth, engage, and transition moves with corner slowdowns. The optimized cut levels can be also based on the scalloped height, as we see in the picture. Basically, this allows for, at the end of a nice Z level, with the optimized cut level set, we'll have a consistent material thickness throughout our model, which is better for our finishing tool path, so we don't overload the tool in any areas during our finished tool path. And additional cuts in shallow regions for uniform surface finish is also a great tool with the ability to cut between levels, as we see in that in the picture. So NX CAM has a unique tool path called streamline machining, and this is a high-speed machining tool path. It creates a great finishing tool path. The beauty behind streamlined machining is the fact that it's independent of your surface geometry. So inside of areas that we see on this part here where there's multiple surfaces, NX-CAM, or traditional CAM softwares I should say, will treat each one of these surface faces independently, and you'll see your tool path jump around. With your streamline, it makes more of a flow, a nice even flow across that, that surface, which provides more of a natural shape of the machined area for a lot better surface finish. Also, with inside the NX-CAM and the toolpath algorithms, we have the synchronized point distribution, which with some of the traditional CAM softwares or some of our competitors will have the misaligned points on adjacent passes, which ends up resulting in a less desirable surface finish. With NX-CAM, it's a synchronized point distribution. So as you see in this image here, with your traditional software, you're going to have more of a surface finish that's certainly less than desirable, going to result in some benching, some handwork, which is time, which is going to take money, which is going to cost money. NX-CAM, it's more of an even distribution of those points, so we get a lot better surface finish at the end of the cut. In the mold and die industry, we're seeing more and more 5-axis machines coming into play, and not just 3+2 machining, but actual full 5-axis machining. And with NX 7.5 and NX8, there was a new tool created that will allow NX to automatically convert a 3-axis finishing tool path to a 5-axis tool path. The tool will automatically tilt in areas that it needs to. So, for instance, if the machine can get away with a 3-axis move and we don't have any collision or with the tool holder or with the tool, then it will still continue with that 3-axis operation. But in an area where there is a collision detected, it will automatically adjust the tool path to tilt. And a quick demonstration here will show how this works. One second. My video went down. I apologize. I'll have to bounce back into the slideshow. With NX-CAM as well, in the finishing toolpath arena, there's some feed rate optimization tools that are available, which will automatically analyze your toolpath and the material removal rate and adjust accordingly. So as we see in our diagram here, the top picture indicates the material that we're machining and the geometry, I should say, that we're machining. And we see the peaks and valleys with the material removal rate. While the feed rate stays consistent across there, we are in some areas we're not removing as much material. So in these areas, we obviously want the feed rate to increase because our machine is no longer removing material in those areas. With NX-CAM, it has the ability to automatically optimize that without having the controller actually have to do it. NX-CAM can. And you'll see that we get a more, in areas where material isn't removing as much, the feed rate is a lot better, a lot faster. It'll speed up in those areas. NX-CAM has the specific capabilities to add value to the high-speed machining approach, which includes features that are important to high-speed machining, whether it be roughing patterns that maintain constant chip load to effective rest milling strategies, smoother finishes. Tools consistently perform at their maximum material removal rates, which is crucial in the mold and die or high-speed arena. Tools last longer because overloading and damages are prevented, and hard milling produces better parts with fewer electrodes. So in the high-speed arena, we're going to chat a little bit about the specialized roughing patterns that come with NX-Cam. For instance, the trochoidal milling that we see up in the right-hand corner for consistent tool load. The nice thing with NX-Cam and the toolpath algorithms, it'll automatically calculate. When it calculates the toolpath, it'll only use trochoidal milling in areas where it's absolutely necessary. When the tool is not being overloaded, you won't see a trochoidal toolpath, which results in a little bit faster speeds and feeds, and the ability to use a smaller tool, or I should say a shorter tool in a bigger area. We also have the ability within the NX-Cam to do smooth roughing, which is providing rounded corners in all of our roughing routines so we don't get any sharp turns inside of NX-Cam. And also the high material removal rate, or the MMR, which we talked about in the previous slide, the optimized material removal rate, which obviously will result in chatter-free machining parameters. So we talked a little bit about the in-process workpiece, but to go into it a little bit further, NX-Cam in the high-speed environment will automatically calculate for uncut materials based off of the in-process workpiece. So we can go in on our roughing routine, use a larger tool, come in with our semi-rough, a little bit smaller tool, and NX-Cam will automatically avoid machining areas that have already been removed by our larger cutter. Obviously results in some optimized rest material and re-roughing, targeted for the semi-finishing methods, and leaves consistent material for consistent finish cuts. After we've done our roughing and our semi-roughing, some of the toolpath that NX-Cam provides for the finishing, one of which being the streamline, which we discussed a little bit prior, is a nice smooth flowing toolpath that transitions great over the surfaces, even if your surfaces are broken up. Smooth, engaged retracts and step overs with some precise control over the step over and the depth of cut. Obviously, the better quality finish that we have, the less bench time that we're going to have on the part, reduces the time, increases the cost, or I'm sorry, reduces the time, reduces the cost. So chat a little bit about the 5-axis milling that NX-Cam provides. 5-axis machining enables production of complex parts with fewer operations and setups. NX provides a wide range of cutting strategies, precise control tool axis, with some great Z-level method with automatic tilting capabilities, and with the new convert 3-axis to 5-axis works extremely well with the Z-level machining. Smooth flowing, so the streamline that we've discussed in the 3-axis realm can also be applied in the 5-axis arena. And where we set ourselves apart a little bit with competition is some of our G-code driven machine tool simulation, which we'll discuss here in a little bit. So with NX-Cam in the 5-axis arena, there's a slew of 5-axis milling toolpath that's dedicated to finishing. We are able to cut with either the bottom or the side of the tool, which some of our competition will only be able to calculate maybe for the bottom. We can also calculate with different toolpaths where we use the side of the tool. Utilizing lead or lag tool axis control. In certain arenas like the turbo machinery, we have directly addresses common airframe programming and tool axis methods to match the geometry. So as you see in the bottom screenshot there, follow wall bottom, this helps users to minimize the selections that they have to make when it comes to 5-axis machining. Less clicks, less picks, we're able to get the program out to the machine much faster. With the Z-level cutting that NX-Cam brings to the table in the 5-axis realm, uses tilted tool to machine deeper walls, obviously with a shorter tool, a little less chatter, which ends up resulting again in a better quality finish with less benching. reduces the tool deflection and minimize tool wear and increase productivity. So tool life will start lasting longer, again, which reduces the cost, the overall cost of machining. The streamlined cutting that we talked about in the 3-axis environment can also be applied in the 5-axis. We can still utilize the nice flow of the streamlined cut, but now we have the ability to tilt the head or table, whichever way your machine tool is set up. It provides us with a smooth tool path, follows the natural shape of the machined area for superior finish. Flexible cut patterns can be handled in any surface geometry, regardless of construction method. So whether or not it's imported data or whether it's an imported solid model or imported surface data, NXCAM has the ability to machine it. So the 5-axis milling environment, we talked about a little bit earlier how we set ourselves apart from the competition is with the G-code driven machine simulation. A lot of times with our competitors, they'll have a tool path verification, which is just imitating what we're seeing from the tool path inside the virtual environment. So it's just running off the vectors of the CAM solution. It's not running the actual tool path through the post processor and running the validation on the G&M code. With NXCAM, we have the ability to post-process and actually use that G code to drive the machine simulation, which ends up meaning that whatever we see on the computer screen is exactly what's going to take place out on the machine floor or out on the shop floor. Siemens provides a complete solution set to define a part manufacturing plan and take it to the shop floor for execution. This diagram that we're showing here represents our view of a complete part manufacturing solution. It extends from the part model preparation, which would be more of your NXCAD, all the way to the design, to the production, and out to the shop floor. And this solution combines all of the Siemens PLM software, manufacturing, engineering applications, and it also we can connect with the Siemens Motion Control, or the Siemens Sinumerics. It also, in this diagram, shows it being managed by Teamcenter, which obviously can manage all of your CAD data through your CAM, manufacturing data, and even down to the tool management. So, quick summary here. We touched base on the 3-axis to 5-axis in today's webinar. A couple of upcoming webinars that we have going on. Tuesday of next week. I'm sorry, not next week. A couple of weeks from now, July 17th. It'll be at 2 p.m. We'll be covering reducing the NC programming time. And the following Thursday, July 19th. We'll be discussing the automated mold design. So we'll be discussing a little bit over the Mold Wizard. And with that, again, I'd like to thank everybody for their time here this afternoon. And coming out, I'll open it up for questions if anybody has any. Otherwise, again, I appreciate everyone coming out. My contact information is below. If you'd like to see a more product-specific CAM demonstration, feel free to get a hold of me and we can schedule a time to get together. All right, with that, no questions rolling in. You can type in the questions in the GoToWebinar box that should be up. But at this point, I don't see any coming in.